Alright, it's John here again, and I want to take a second look at the Euler 2 problem because if we look at the solution we came up with, it was a recursive function that started out okay until we needed to call it a bunch, and we had to put in some kind of workarounds with basically memoizing and caching results and reusing cached results, and that made our solution pretty messy. So I kind of looked around at what other people did and realized there's sort of kind of a hole in my suite of weapons in Clojure, and that is the use of lazy sequences. So I saw some other people that use lazy sequences, and it made the solution a lot more elegant. So let's develop a lazy sequence solution here and see if we can have a more elegant answer to this problem. So we are basically going to define a Fibonacci function that will return, it's going to return the sum of the previous two values. And to do this with a lazy sequence, we are going to pass in the current value and the next value. Okay, that way we just sort of build this thing up by its definition in a way. So we are going to cons the current value onto the sequence. So it's going to be a lazy sequence, and that sequence is going to be the next value. The sequence is going to be the Fibonacci function using the next value and then the value after that, and we know the value after that is the sum of the current and the next value. Okay, so just kind of looking over that one more time, we're taking a Fibonacci function, we're going to take the current value in and the next value in. We're going to add the current value onto the sequence of the next value and then the value after that. Okay, so we can define that. We can execute that, and we can call it with 0 and 1. Right. We just called an infinite series, so that is going to cause a stack overflow. That's not what we want to do. So let's do take 10. Let's take 11 of this series, and we get 0, 1, 1, 2, 3, 5, 8, 13. Alright, so we get the, we take 12, and we basically get the Fibonacci sequence from Project Euler like they're talking about. It looks like if we shifted our starting position up, then we have 1, 2, 3, 5, 8, just like they have. Okay, so we can get the Fibonacci sequence by calling this with a initial value 1 and 2. So let's go ahead and overload the arity of this function and make, if we have no arguments, then we're going to call this function with 1 and 2. So now we need to add in parentheses here and there. So now we can do take 12 and just call this with no arguments. Let's not forget to define that. Okay. call that with no arguments, and there we go. That's working as expected. So let's go ahead and use it to solve the problem. So we're going to call fib. We're going to take while the answer is less than 4 million. And then we are going to filter that result out to only take the even values. And then I was using apply last time. We can also use the reduce function. We can reduce the whole. We can reduce the whole collection with plus, and that should give us the right answer. So let's go ahead and try that out. And that gives us 4613732. Okay, so now we got the right answer. But I'm still a little bit dissatisfied in that we have this big nested construct. It doesn't look very, it looks lispy and not very Clojure-y. So we're going to use a threading macro to make this kind of flow top to bottom instead of inside to outside, right to left. So basically we want to start with the Fibonacci sequence, and then let's do let's start with take 10, take 11. I think could give us, or take 10 will give us what they're talking about. Let's just test that out. Okay, good. So with this threading macro, we give it the function that returns us our sequence. Then we call this sort of partial function in this macro, and it's gonna insert our argument in the right place. So now we can change this to take while less than argument 4.0 e to the 6. Okay, so now we should get a lot more. There we go, we got a lot more. And now we can do our filter even on that result. Now we just have the even values, and we can do a reduce plus, and that gives us the final number. So there we go. So now we've taken, I can delete that. So now we have a very small, elegant definition of the Fibonacci series, and then a sort of more stepwise look at how to solve the problem by taking only a certain amount and filtering out and reducing. And I think that's a lot more readable using this threading macro. So and I feel a lot more at peace with this Project Euler solution than, or Project Euler solution than this here. I think this looks nice and clean, and I think we can be proud of this solution. So thanks for watching.